Hey chemistry, it's Mr. Aiden, and we're going to be going through a video on titrations. Titrations are a really important part of acid-base chemistry. You got to know how to do a titration, you got to know how to interpret a titration, you got to be able to calculate a titration. So titrations are very important, so let's get to it. So what a titration is doing is you're trying to find out, we always want to know the purpose of what we're doing. And the main purpose of what we're doing is trying to find out the concentration of an unknown solution. So let's say down here at the bottom we have an unknown solution, and this is called the analyte. Okay, the analyte is something we're going to analyze, and I don't know his concentration. So that is the big question mark, is this is the unknown. I don't know his concentration, his molarity of his solution. But what do I know is I can measure him out and find out his exact volume. So let's say it's 50 milliliters or 100 milliliters. I have to know his volume of his solution. And so the next thing is, and let's say this is an acid. Okay, so we have an acid. I don't know his concentration, but I know his volume. And let's say we want to titrate it. We're going to titrate it with what's called a titrant. Okay, a titrant. A titrant is a solution, and so let's say in this titrant I have a base right here. Okay, and this base, I know his concentration. Let's say he's like 0.1 molar of a base, let's say a strong base in this case. And I can know his initial volume, and I can titrate him. I can drip, drop him in, and I can find his final volume. And so I can know how much volume of that base I used. And so if I know his concentration, and I know his volume, and I know the acid's volume, I can actually know the acid's concentration. Now we put this titrant, this base, in a glass cylinder called a burette. So we call this guy a burette. This big long piece of glass that we can drop the base in. Okay, and the main equation we're going to use is M1V1 equals M2V2, and you can see I need to keep consistent. So I need the acid to be on one side. I need to have the base on the other side. Okay, and so let's say I don't know my molarity of my acid. That's my big unknown. But let's say I do know the volume of my acid. Let's say I use 50 milliliters of this guy down here. I use 50 milliliters. And let's say I know the concentration of my base is 0.1 molar. Okay, and let's say I use a volume of about 44 milliliters. Remember, that was the change in the volume, was 44 milliliters. So I put 44 milliliters right here. And this is a pretty easy math problem. 0.1 times 44. I divide by 50, and I end up getting my concentration of my acid ends up being 0.088 molar. Okay, and so you can see how I can find out the concentration of an unknown. And we use this within industry all over the place to find out the acidic concentration in soils, acidic concentration in solutions, in people's stomachs, all kinds of things. We will use a titration. So we have two things we need to know about a titration. Is we need to know the equivalence point and the end point. They're two different things, but they're going to be very similar. Okay, I want them to be relatively the same. Okay, the equivalence point is when the number of moles of acid are equal to the number of moles of base, and that's when I use M1V1 equals M2V2. So I'm going to use a calculator. I'm going to calculate to find the equivalence point. But the end point is when the color changes. So this is what you can see with your eyes, is when the color changes. You can see I have a clear solution here. It starts getting pink, and once it gets totally pink, that is when I hit my end point. Okay, and hopefully I want my end point to be very similar to my equivalence point. And so the end point is when you're seeing something happen that's more qualitative. The equivalence point is more quantitative when you're calculating what's happening. Okay, and to find the end point, we use a bunch of different indicators. Okay, the main indicator we use is our pink one. The one that you saw in that previous picture, that's phenolphthalein. Phenolphthalein, you can see, is a great indicator because it turns pink right around that 7, 8, 9, 10 area, and so that's a great one to use for strong acids and strong bases. Another one we use a lot is this one right here we call bromothymol blue. Bromothymol blue is yellow when we are an acid, okay, and it's a blue when we're a base, okay, and so you can see that helps us figure out about a pH of 7 when we change from an acid to a base. So these are the two main ones we're going to use in class, is bromothymol blue and phenolphthalein. Number one, because they're cheap. Number two, because they work. Another great one would be universal indicator. Universal indicator indicates when you have an acid, when you have neutral, and when you have a base as well. Okay, so one thing we need to take a look at, we know we hit a color change when we have our end point. How would we know we have an equivalence point? Is we would need to do our titration with a pH meter. And so this is a strong acid at the bottom being titrated with a strong base. So a strong acid would start off at a very, very low pH, maybe like pH of 1, okay? And so you can see how we're going to have a pH meter in my solution, and as that pH meter is in my solution, it's reading the pH. And so we're going to start dropping my base. Drop, 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 drop. It's barely going to change the pH, okay? And so then what happens is, right when we get close to the equivalence point, right when we get close to the number of moles of my acid equaling the moles of my base, the pH just skyrockets up, okay? And it keeps going up, 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 up until I'm totally a base, and that's when I'm a base. And this is what the graph looks like for a strong acid with a strong base. How would you know when you have your equivalence point? That would be right here at a pH of 7. That would be at my equivalence point. That's where the number of moles of acid are equal to the moles of base. And how come the pH is equal to 7? Well, think about it. If I have a strong acid, I have H+. If I have a strong base, I'm titrating with OH-, and that's going to make H2O, or water. You can see how I can know this is how much volume of my base I need to put in. So let's say we go to M1V1 equals M2V2, and let's say my acid, I don't know his concentration, but let's say I have like 15 milliliters of my acid in my at the bottom. So I started with 15 milliliters. Well, when I hit my equivalence point, let's say I have 0.1 molar of the NaOH. So that's 0.1 molar of my base. How much base did I use? I used 20 milliliters. And so you can see I'm using M1V1 equals M2V2. I have 0.1 times 20 divided by 15, and that gives me a molarity of my acid is 0.13 molar. And that is what a titration curve looks like of a strong acid with a strong base. One last one is what does it look like if I have a weak acid? Let's say down here I have HA, a weak acid, and I'm titrating with a strong base. A weak acid is going to be closer, it's going to be higher in its pH right off the bat, and then I start drip, 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 dropping with my base, and then whoop, it goes up, and you can see how right here my equivalence point is right here in the middle, my equivalence point, and my equivalence point, you can see, is above 7. It's not at 7. Okay, which, think about the reaction here. I have a weak acid. I'm going to call him HA plus OH minus. Sorry, not H2O. OH minus. And what do we know bronze-cellulari weak acids do? They give away what? What do they give away? H plus. And so what do I end up getting? I get water and A minus. And what do we know A minus is? A minus is called my conjugate base. How come my pH was above 7? Because what did I have in my solution? I had a conjugate base. You would still take a look at how much volume you put in by doing this. It's the same exact equation for a strong acid and a strong base, as well a weak acid with a strong base. It's M1V1 equals M2V2. And that is titrations. Make sure you go do the titration self-assessment on MrAiden.com, and hopefully this made a great amount of sense. Titrations are a very important part of chemistry honors, and so make sure you know how to do a titration. I'll catch you on the flip side, yo-yo. Keep it real. Peace in the Middle East.